What happens when ice melts? A solid subject such as ice will gain heat and will be converted into a different form of matter, which is gas. We all know that, but what if I told you that it's way more complicated than that? There are driving forces such as enthalpy and entropy and more. We're going to explain chemical thermodynamics. First, let us explain how ice melts without the concept of chemical thermodynamics.
Ice is the solid form of water. It forms when it reaches its freezing point, which is 0 degrees. And ice melts when it reaches its melting point, which is also at 0 degrees.
The melting of an ice can also be explained through intermolecular forces. Since all matter have intermolecular forces, ice has hydrogen bonding.
The hydrogen bonding found in ice is broken when it reaches a specific temperature, 0 degrees to be exact. It gains heat and energy for it to reach that temperature, thus allowing it to melt.
But did you know that the melting of ice is a spontaneous reaction?
What is a spontaneous reaction? Not to be confused with the word spontaneous, which is to happen suddenly, but a spontaneous reaction is the reaction of favors of the formation of products at the conditions under which the reaction is occurring.
There are two things to understand when it comes to spontaneous reactions: entropy and enthalpy. Take for example ice and water. Water has higher entropy than ice because it is a liquid state of matter. The molecules of liquid have more freedom in space than the molecules of solid, which are compact. So, solids have lower entropy than liquids because their molecules are more orderly.
Now, what about enthalpy? Enthalpy, as we learned in the previous lesson, is the sum of internal energy and the pressure-volume product of a system. It is similar to energy but not entirely the same.
Now, how is the melting of ice a spontaneous reaction? A spontaneous reaction occurs when the entropy of a system increases and its enthalpy decreases. The melting of ice is an exothermic reaction. During an exothermic reaction, the energy of a system is released into the system, therefore decreasing its energy, which is a decrease in enthalpy. And since the solid state of ice is turning into liquid, the entropy increases since the molecules of liquid are more disorganized compared to the particles of solid. So there you have it, guys. It is important to know that the change in enthalpy and entropy are the driving forces behind all chemical reactions. Always remember that a spontaneous reaction is a chemically favored reaction, and it occurs when the enthalpy of a system decreases and its entropy increases. That's it for today, guys. Thanks for watching.